Hello everyone and welcome back to chapter 18. We are finishing up with Wednesday and Thursday's lecture on lesson 18.4, which is energy from hydrogen. Our guiding question for today is, or for the next 2 days, is how can we use hydrogen as a source of energy? So we're going to kind of go through that whole process. But first, the image we see in front of us is actually a space shuttle, and we can see the rockets are actually being powered by hydrogen fuel. So that's pretty cool, and we're going to get into how exactly that works coming up. Oops, excuse me. Skipped ahead there for a second. So chapter 18.4, by the end of the next 2 days, we're going to be able to describe how hydrogen fuel can be produced, and then we are going to explain the way fuel cells work and how they are used. Our vocabulary is electrolysis and fuel cell. So go ahead and turn in your workbook and jot the definitions down. Once you're done with your vocabulary, just continue on whenever you're ready. So hydrogen is the simplest and most abundant element in the universe. In its elemental form, hydrogen is actually a gas, and its chemical formula is H2. Hydrogen gas can be burned to release energy that in turn can generate electricity. When it is burned to produce energy that people can use, hydrogen gas is called hydrogen fuel. Its combustion is clean compared to fossil fuels. The U.S. space flight programs have used hydrogen fuel since the 1960s. Hydrogen gas is actually very rare on Earth because hydrogen is going to be found in its chemical formula, and it's going to be bound to other things. So, for example, hydrogen is commonly found in water, H2O, where the hydrogen is bound to oxygen, or in methane, which is CH4, which you have 4 hydrogens bound to a carbon. So we have to find ways to release hydrogen. The compounds that contain it must be broken down chemically in order to get the hydrogen by itself. Why are environmental scientists interested in hydrogen as a source of energy, though, since it's not readily available? Well, one reason is that hydrogen fuel can be stored and transported from one place to another. So, unlike most other sources of renewable energy, we cannot transport the wind from North Dakota to North Carolina, for example. And we can't move the sun from Arizona to the state of Washington or Seattle. Someday, however, energy from the wind in North Dakota may be used to create hydrogen fuel. So this is why they're so interested. The hydrogen fuel can then be transported to places like North Carolina or Seattle, Washington. The possibility of hydrogen fuel is the key to its potential usefulness. So hydrogen gas is actually combusted to produce heat, and the only byproduct we actually get out of the reaction is water, which of course is H2O, and it is not a pollutant. It's something that we have readily available on Earth, which is a wonderful thing. So how do we produce the hydrogen fuel if the hydrogen gas isn't found here normally? We actually have to find hydrogen containing compounds like we were talking about, and then they must be forced to release those hydrogens somehow. And so the chemical breakdown of the hydrogen containing compounds requires an input of energy. So the first example is electrolysis. This is one process that releases hydrogen. So we have water molecules are actually broken down into oxygen gas and hydrogen gas by an electric current that runs through the water. So you can see here we have a cathode, which is a positive charge, and an anode, a negative charge. And we have water, H2O, in the container, and as the charge and the current flows, we end up getting oxygen gas and hydrogen gas separated out. So again, we can see this in the depiction of here, or we can see it in a chemical formula here. So two water molecules undergo electrolysis, which is subjected to a small electric current, and then that breaks apart the hydrogen and the water, so we end up with two H2 gas molecules, hydrogen gas, and then we end up with oxygen gas. So electrolysis actually produces pure hydrogen gas as well as pure oxygen gas. And the process does not emit any greenhouse gases or pollutants. However, electrolysis of water is a pretty costly way to obtain hydrogen. So just to summarize, what is electrolysis? It's actually the process which water molecules are broken down by an electric current into hydrogen and oxygen gas. So what's the second way? The second way is the breakdown of methane. Hydrogen can also be extracted from the methane, which is found in natural gas, or is a natural gas. This process is less expensive than electrolysis and is now the most common way of obtaining hydrogen. The following equation summarizes the reaction. So we have CH4, which is methane, plus 2 H2O, water, results in the reaction ends up giving you, see, this is the input, and once those react together, this is the output for hydrogen gas molecules and CO2. So that's the downside to this reaction. It is the least expensive, or it is less expensive than electrolysis, but it ends up releasing carbon dioxide. And we know that carbon dioxide is a greenhouse gas. So even though we're getting our hydrogen gas out of this reaction, we're also creating a little bit of carbon dioxide in the reaction as well. So therefore, energy experts do not want to see this method of breaking down methane as the preferred long-term source of hydrogen. We definitely would prefer to find a cleaner way that doesn't produce any greenhouse gases. And there are some new ways, or some other ways. So there are disadvantages to both methods that we just described, electrolysis and the breakdown of methane. So therefore, scientists are they're investigating and researching different ways to obtain hydrogen. And for example, the heat given off by a nuclear reactor may one day be used to split water into hydrogen and oxygen. So that's one way that we could do it. And another way is using technology by using some live organisms. So we can actually use green algae to produce hydrogen gas from water. So these microorganisms, algae, we can see them in the image here, and the algae, the microorganism, is actually what's causing the liquid in the container to turn green or appear green. And then this algae solution actually is what creates the hydrogen out of the water, just from the metabolism and metabolic processes of the algae. So let's take a look at benefits and cost of energy from hydrogen. So as a fuel, hydrogen has a number of benefits. Because it is the most abundant element in the universe, we're never going to run out of it. But depending on how it is made, it produces a few greenhouse gases or pollutants. Water and heat may be the only waste products generated by using hydrogen as fuel. Ideally, it would be. So hydrogen can be stored and transported from one place to another, which was a huge benefit. And hydrogen gas can catch fire. But if it's stored properly, it is probably no more dangerous than we would consider gasoline to be. However, processes that break compounds down to release hydrogen, such as electrolysis, requires energy inputs. With the technology now available, hydrogen fuel is expensive to produce. So in addition to being useful in motor vehicle, hydrogen needs to be compressed or squeezed into a smaller volume. Scientists are working on ways to do this safely. All right, so here we can see an image of a hydrogen-powered scooter. So this is considered an electric scooter, and it runs on this fuel cell battery that you see on the front of it. But the question is, why are hydrogen-powered motor vehicles so uncommon? Well, it goes back to the idea that, first of all, we need we have to put energy in to get energy out is one of the issues. And the fuel is very expensive to produce. And then on top of that, it needs to be compressed in order to be used by motor vehicles. So the volume is too large for what we need to actually propel a large vehicle forward reliably. So it's just too high of a cost. But the batteries are getting better, the technology is getting better, and so we're not seeing this as big of a hurdle as we once did. This finishes up Wednesday's lecture. So go ahead and turn in your workbook and answer questions 1 through 10, and then we'll come back and finish talking about fuel cells and finish up chapter 18.4 tomorrow. Have a good day, guys. All right, hello everyone and welcome back. This is Thursday's lecture and we're talking about 18.4 and we are looking at how hydrogen as fuel, and we're talking specifically today about fuel cells. So remember, hydrogen gas can be used to produce electricity and that's what's being done in these fuel cells. So the chemical reaction that takes place in a fuel cell is the reverse of the reaction for electrolysis. So electrolysis, if I could remind you, we started with water, H2O, and then we ended up getting hydrogen gas and oxygen gas. But in a fuel cell, we're going to do the reverse. So we're going to start with 2 hydrogen gas and oxygen gas, and then once that reacts, those are going to bond together and the byproduct or the end result is going to be water. And we end up actually getting 2 molecules of water as a result. In addition to water, we get water vapor, we get heat as a byproduct. This reaction can power vehicles and it can also power power plants, and it can provide electricity to off-grid or unreachable places that don't have access or don't have readily available access to electricity. Sorry guys, I'm getting a little tongue-tied. All right, so let's take a look inside an actual fuel cell. So a fuel cell has a positive electrode and a negative electrode. And as you can see on the image on your screen, we have the negative on the left side, negative electrode, and the positive electrode. Reactions in a fuel cell result in electrical current that is flowing through the wire from one terminal to another. So we can see here the flow of electricity, right? And like we saw on our chemical equation, we have hydrogen fuel coming in to this chamber. And then we have oxygen gas coming in here. Inside, this is a hydrogen gas solution, and as the negative and positive electrodes, as electricity runs through here, it excites these molecules, and they are able to break apart. And split into these hydrogen ions. And then that causes an electric current to flow from one terminal to the other, and then the byproduct here, we see the hydrogen bonding with the oxygen, and we are getting H2O water molecules as a byproduct. Of course, you also get some heat with this. So hydrogen gas, just to go through it again, enters the side of the cell with the negative electrode next to it. And each hydrogen molecule then splits into two, so you can see there are two here. One of these molecules splits into two positively charged hydrogen ions. Meanwhile, the oxygen gas is entering in the cell through the positive next to the positive electrode. And a series of reactions occurs to make, which makes two things happen. First, the reaction causes an electric current from the negative terminal to the positive terminal. As that is taking place, the oxygen and hydrogen ions combine to form molecules of water. So how are the fuel cells actually used? So they can be used in many ways. They can actually provide power for moving vehicles. The city of Hamburg in Germany has buses powered by fuel cells. We're seeing a lot of actually new technology in electric cars, the Teslas and things like that. But in fact, vehicles ranging from cars to even space vehicles use hydrogen fuel cells as an energy source. However, such vehicles are not as common as you think that they might be. Fuel cells can supply power in places that are far from conventional utility companies that produce electricity, and other technologies can be combined with fuel cells to accomplish this. One example is the system built on Stewart Island in the state of Washington, and their solar power produces hydrogen, which is then used in fuel cells to produce electricity. All right, that wraps up Chapter 18.4. Go ahead for classwork and turn in your workbook and answer questions 11 through 17. Guys, don't forget to feel free to use your answer keys that I've emailed out, and are also posted on LMS. We do have a homework tonight So that is 18.4. You can see it listed below, just 3 questions. You can copy this and email me your answers, or you can go on pearsonrealize.com and complete the assessment there. All right, again, if you're following along with the lecture, I want to reward you by having a quick peek. So go ahead and take a look over this and get those homework assignments posted. All right, guys, I hope you have a wonderful weekend, and we will continue next week with Chapter 19. Bye, guys.